The RainBloc System, water-repellent concrete masonry units, or CMU, are used primarily in architectural single-width masonry walls. This means that the units are usually on the outside of the building, where they are visible and are a feature of the building design and appearance. These exterior units need to be water-repellent to prevent moisture from moving from the outside of the building through to the inside. As we know, regular CMU have a high volume of voids, usually around 10% by volume. So CMU are porous, meaning that the moisture can migrate or move through them. Rain, especially wind-driven rain, is the most common source of moisture problems. There are a few things we can do to prevent moisture ingress. A very effective solution is to add a water-repellent admixture like RainBloc. Adding RainBloc to the concrete mix helps in two ways. It reduces moisture penetration at the surface. We can see how this works through water beading. Here's an untreated CMU, and we can see how the water disappears as it is absorbed into the unit. By contrast, notice how the water bead holds onto the surface of our RainBloc CMU. RainBloc also reduces the wicking action that draws moisture through the interconnected voids from the surface further into the unit. RainBloc is actually a water-repellent system for masonry walls. The system includes a water-repellent admixture for the CMU and a masonry mortar additive. It makes sense that we have to treat both the CMU and the mortar to ensure the whole wall resists moisture penetration from the wind-driven rain. If the mortar is not water-repellent, it creates a weak spot that moisture can enter through. CMHA, or the Concrete Masonry and Hardscape Association, has developed a standard spray bar test used to visually assess and evaluate the water repellency of CMUs. This is a test that simulates wind-driven rain events and scores a CMU's ability to resist water penetration. In the spray bar test, a spray bar equipped with multiple nozzles is positioned next to a CMU. Water is sprayed continuously onto the unit's exposed surface or face for a specified amount of time, and the interior of the CMU is then visually inspected for signs of moisture penetration. The spray bar test evaluates where the CMU remains dry or exhibits damp areas or pinholes on the interior surface. Here are some examples of dampness, which we can see by the darkening color. Pinholes are a single point source of moisture that may trickle down the interior face of the unit. Why should we do the spray bar test? The spray bar test offers a relatively inexpensive and time-efficient method to assess a CMU's water repellency. It does two things. It helps confirm the presence of water-repellent admixtures, so it confirms the water-repellent admixture was added to the mix, something we always want to know before the units are installed. And it is a warning that there may be potential weaknesses in the unit's ability to resist moisture migration. When we get a poor result, we can investigate what's causing the issue and implement corrective action, again, before the units are installed. To find out more about the spray bar test, we have videos which cover how to perform the test and how to evaluate the unit performance. See you next time on the ACM Academy.